Hello everyone, welcome to Proof of Concept channel. As part of POC today, we are going to see XGBoost based model building for the regression problem. We took a problem of the load Boston, the housing dataset. Using that dataset, we are going to predict the price, the target price of the houses using the XGBoost Regressor. Earlier videos we seen that XGBoost classifier to classifying the classes, the wine classes. However, for this video we are going to use XGBoost Regressor for the regression related problems. The objective of this proof of concept is to build a machine learning model using XGBoost Regressor with the sample data given by the sklearn. So we are going to use the sklearn housing dataset to predict the prediction of the houses. Following are the steps involved in this process: load required libraries, import dataset, EDA Univariate Analysis, and Bivariate Analysis, model building. We are using XGBoost Regressor here, and model analysis. Save the model as a Pickle file, load the model to get a prediction using the test data, and a summary. Let's start one by one. The step 1, load required libraries. We need all these libraries. So especially for the data sets, we are using the load Boston. It's a housing data set. So we are using this data set, and we are using the mean squared error and the matplotlib for plotting purpose, Cbon, and the XGBoost we are using that regressor. Similarly, for save and load the model, we are using the Pickle library as well. Let me run quickly. Okay. So the step 2, we are going to import the dataset. So we are loading the Boston dataset. So it's in the data frame right now. You see the target I renamed as a price. So we have the Boston housing dataset with the target as well as the features. Okay. So here these are all the attributes we have, the independent variables, and the price is the target variable, housing price. So based on these independent variables, our model is going to predict the price of the house, and we are going to see how the house prediction is getting affected based on these attributes, especially the NOx, oxide, as well as number of rooms, as well as the age. All those things are factors. Quickly see the shape of the dataset. So we have 506 records and 14 columns. This is including the target columns. And to this step, we are seeing the description of the dataset. So these are all the attributes we have. During our previous videos, we explored all these attributes already. However, let's see quickly how these attributes are contributing towards our model. Especially if you see here the CRIM, the per capita crime rate by town, and CHAS, Charles River dummy variable, 1 if tracks bound river, 0 otherwise, and nitric oxide concentration, NOx, and average number of rooms per dwelling. Similarly, for the age, proportion of the owner occupied units built prior to 1940. So these are all the independent variables make a influence of our model. We are going to see that soon. And if you see here, this is our target variable MEDV, median value of owner occupied homes in thousands. So I just renamed as a price. However, this is our target variable name. Let's see the information Boston dataframe.info, and here we can see how many records we have for every attributes. Here if you see, it's a 506 entries, and the data type is a float data type. Yeah. So in this step, we can see mean and the median value, especially the NOx. If you see the mean and the median value here, 0.5 and 0.53. Mean and median value is same. And average number of rooms per dwelling, so that you can see the average number of rooms. We can see 6 rooms and minimum 3 and maximum 8.7. We can do some kind of analysis based on this. especially the mean, median, and the 75 percentage max, all those details. I have some observations here. Mean and median value of NOx is 0.555, and average number of rooms per dwelling are 6, and the minimum value is 3.5, and max is 8.7. Let's check the null values. Yeah, so we don't see any null value because this is the toy datasets. We are not seeing any null here. In case if we see any null in the datasets, we may need to consider the imputation, null value imputation as part of the analysis. So this is alternative approach to check the nulls. We are checking the same thing here as well. So this step we can see already. We know that 506 records for these data sets. So we are not seeing any less records, which means we don't have any null values anywhere. We are in the step 3 right now. We do some analysis based on this. Check the unique columns first. The data frame dot n unique that provide us the unique columns. So if you see here, these are all the unique records that we have, especially CRIM we have 504, and the NOx we have 881. Here we are using the histogram and plotting the age. Let me quickly run this. Yeah, this graph for the age distribution, building age distribution. So proportion of the owner occupied units prior built to 1940. So based on this graph, if you see 160, more than 160 owner occupied units built prior to 1940, we can see the count of this. Next we are using Histplot to see the CHAS distribution. Yeah, so the CHAS is the Charles River dummy variable. So this indicates if it 1 means if the track bounds river, 0 means otherwise. So this is the analysis we are going to do now. If you see here, as part of this graph, we are seeing that 0 is more the count, and very less 1. So which means what this is telling us is CHAS has most of the values equal to 0, which means most of the places have no tracks bounding river. So we don't have the tracks bounding river most of the places, but very small places we have that. And in this step we are plotting the next graph is PT ratio distribution, the pupil teacher ratio by town. When we run this, we see that it's skewed to left. So it's skewing to the left side, and which means the number of students per teacher is very high in most of the areas. So that's what this graph is representing us. Let's quickly do some bivariate analysis. We are using the pair plot, and we given some attribute details here. This graph helps us to see the correlation between the attributes and between the target variable. We can easily see the positive as well as the negative correlation between the attributes as well as the target variables. Okay, we got it. So here we can see the positive correlations as well as the negative correlation based on our independent variables. So especially if you see here the price as well as the NOx. So this is giving us the kind of negative relationship, because whenever the NOx concentration more on the air, the housing price will be reduced. That's what this graph is telling us. Similarly, if you see the room and the price, there is a positive correlationship, which means the number of rooms will be increased, then our housing price also will be increased. That is part of this graph explaining us. Similarly, age, if it's the building age is getting old, then the price will be decreased. And one more observation here. If you see the LSTAT, that's a negative correlation. LSTAT is nothing but the lower status of the population. So when we have the lower status population, then the housing price will be reduced. So those observations are here as part of this graph. We can go through and then see what are all the observations we are getting it. Next, we have a heat map. Heat map also provide same kind of relationship. Let me quickly run this heat map. Yeah, we got it here. So if you see the price and then the knocks, we have the negative correlations. Room, if you see, it's a positive correlation 0.70, and age is a negative correlations minus 0.38. Similarly, for the PT ratio, we are seeing that negative correlation 0.51. LSTAT, we are seeing the negative correlations 0.74. Right now we are in the step 5. So step 5 model building, we are using XGBoost Regressor. So I'm extracting the independent variables as well as the target variables x and y. So the x, if you see, all our independent variables, and then y is just as target variables. Okay. So now the next step is we have to split the test data for the testing and the training purpose. So this test and train split is helping us to do that. I'm just giving the x and y and splitting it. Test size is 0.20, and quickly run this. So in this step we are building the model. So if you see that XGBoost Regressor, I'm using the XGBoost Regressor here. In addition to that, I'm giving some parameters. So if you see here, some hyperparameters details, so especially the learning rate and max depth, similarly n estimators. So the learning rates, this help us to prevent the overfitting. So the range we can give 0 or 1 learning rates. And max depth, this determines how deeply each tree is allowed to grow. So that we are specifying the max depth. If you see the max depth, we given 7. And n estimators, this decides number of trees we want to build. So the n estimators we given 100, which means 100 trees we are growing and then seeing what kind of score we are getting based on these hyperparameters. Okay, now our model is available ready and we are fitting the model. So XGBoost and xtrain and ytrain data. Okay, let's do the prediction based from the model. So I'm just using the .predict method and giving the test data. It's executed right now. Let's do the model analysis here. So we are going to see the score as well as the root mean squared error. So let's see, quickly run and see the score. We are seeing that 90, so which means 90% correct. Our model can able to predict 90 values out of 100 values that we are providing. And this mean square error is the measure of how well a regression line fits the data points. The np dot square root of the mean square error. So here if you see, we are getting 2.7, which means we are seeing that around 2.7% of errors. So basically, if the mean square error is less, then it's very good for our model fit. Next, we are going to see the feature importance. Feature importance refers to a technique that calculates a score of all the input features for a given model. The scores simply represent the importance of each features. So a higher score means that the specific feature will have large effect on the model that is being used to predict a certain variable. Let me quickly run this. So this will give us the score for every attributes. Based on that, we can able to see every so how much contribution towards our model. So if you see here the CRIM, it's contributed 763, that's the score, and the room 508. So these are all very high important features towards our model. The chas and then the tax, those are all less important. So those, so in case we need to remove any of one of these, we can consider this and all. So right now we are in the step 7. Save the model as a pickle file. Let's do that. I'm using the pickle.dump and I'm giving the model name here. Okay. Next step, step 8, load the model to get a prediction. So I'm using pickle.load to open the model. So now our model is available. So the name is loaded model. That's the name it's stored. Let's do some prediction from the test data. Right. So if you see here, I kept all our independent variables as well as the observed price. This is our target variable, and the predicted price. This is the output from the model. So now if you see every records, so the first records we got 28.2, that's the existing value, target value, and our model predicts it 30.05. And 23.9 we got a prediction of 27.26, and 16.5 and we got a 18.7. So it's not exact match, however our model can able to predict very closely for every housing prices. Now you may understand the regression problems. Whenever you have a classification problem, we have a categories, category A, category B, or category C. However, for the regression problems, we don't have that. So we are going to predict the numbers. So that's a difference between the regression as well as the classification applications. So we are in the summary right now. As part of this proof of concept, we have achieved the following steps. We loaded the Boston housing dataset from sklearn, and we did some analysis, univariate and bivariate analysis, and we used XGBoost based model building. We used XGBoost regression for this model, and we did some training and test split, and we built the model, saved the model locally as a pickle file, and loaded the model back to get a prediction from the model. Similarly, we did a comparison between the observed as well as the prediction results. Thank you so much for watching. All these commands as well as this notebook available for you to reproduce. Please try to reproduce and build this XGBoost based regression model, and then see if you can able to get this same result, and let me know in the comments. Also, you don't need to require any software installation or any configurations. If you have a Google account, use this Google Colab and try to execute all these steps. It's completely free.